Hi there, everybody, and welcome to Mondays with Mike. It is Monday, and last Monday in August, I believe. Crazy how fast the time flies. So, hope you're doing well. Hope you enjoyed the weekend. It was hot, definitely was hot, but yesterday we started to notice just a little hint of a change to our weather pattern with lower humidity coming in. And that lower humidity is going to be followed by rain today through the next several days. So today's topic is going to be the top 10 most commonly asked weather questions that I'm going to attempt to answer in a way that hopefully makes sense. Now, where did I find this top 10? Well, I consulted my new friend, ChatGPT. I love ChatGPT. If you haven't downloaded it yet, it's easy. It's free to sign up for. There is a premium membership too if you want to do more stuff with it. But it's just neat. Like I prefer it over Google because if you just want instead of links, like Google will give you links. Although if you try Google now, it will give you an AI answer sometimes depending on the question. It's just kind of a cool thing. So I just went simply to ChatGPT and I said, what are the top 10 most frequently asked weather questions? And so this is what ChatGPT provided me with, and we'll go through them here. What will the weather be like today and tomorrow? We'll start off with that. Why does it rain? What's the difference between weather and climate? How do meteorologists predict the weather? Why is the weather forecast sometimes wrong? Talk about that. What causes severe weather events like hurricanes, tornadoes, or blizzards? Why does the temperature feel different from what the thermometer shows? What are the different types of clouds? What do they mean? Oh, that's cool. Why does the weather change so quickly? And finally, what is a weather front? How does it affect the weather? Okay, pretty good questions. Well, the first thing that we'll start out with, which I'm sure you're interested in, is what's happening with the weather today? What's happening with the weather tomorrow? Well, we do have changes on the way, and I'll show you that here real quickly in this back monitor, because instead of high pressure that was in place for a very long time for us, we have now low pressure that's in place here. And so the area of high pressure that kind of caused some sinking air and prevented very much in the way of rain and really it brought in the strong sunshine and so forth, that's gone. And high pressure has now moved up here to places like Omaha, St. Louis, Chicago, where they're going to have very hot temperatures today, like upper 90s. Last week, they were in the middle 70s, so quite a difference for them. And then around here, the change is resulting in much better rain chances for us. So this is the water vapor satellite imagery. And maybe I should move this so you can see it a little bit better, you think? Yeah. So this is the water vapor satellite imagery here. And the vapor loop is real interesting because the satellite is able to detect the frequencies coming off of water vapor, but mainly in the top half of what we call the troposphere. So it's not necessarily, if it were seeing all the way down to the surface, then it would be real messy because you'd see and anywhere that's humid, which would be, the entire Gulf Coast would be lit up. We don't really want to see that. We want to see the top part so that we can see how the winds are flowing around and where the moisture is getting steered. So in this case, you can see this big counterclockwise circulation indicating what's called an upper low. And so we zoom in on that. It's what's really going to be driving our temperature, our rain chances and temperatures for today and tomorrow. And so it's going to give us a pretty good chance for seeing some rain. And in fact, this is sort of the outlook for the day today. Let's see, let me click on this and show you this futurecast here, just real quick. So this is the HRRR, or the HRRR futurecast. And you'll see, I mean, yeah, it's showing some nice amounts of rain here. I mean, even for the afternoon. So it's not going to be just a nonstop kind of thing, but it is giving us a pretty good chance for seeing some rain here, not just today, but actually taking us all the way through the remainder of the forecast period through the next 7 days. So that's sort of the answer to question number one, is that the weather is going to be wetter than last week. Sorry, I'm just looking at the clock. It's going to be wetter than last week. It is going to be not as hot as last week. We had 2 weeks straight of heat advisories or excessive heat warnings. So that definitely is going to be changing. And hopefully we won't get put under any kind of flood watches or anything. Right now, the rain is kind of regular rain, regular thunderstorms, and we can handle that, right? All right, so that's number one. That's easy. Number two, it gets more interesting. Why does it rain? This is an excellent question. This is the kind of question that we would get, out of school talking to kids, especially elementary schools. Why does it rain? Well, one of the amazing things about living here on planet Earth is that given our temperature and our pressure that we have, that we live in, our water can exist in 3 different forms: ice, liquid water, and water vapor. And sometimes it can exist that way all at the same time. For example, in a cloud. So in a cloud, you have water vapor, which is invisible. That's mixed in with the air. It's the gas form of water. You have raindrops, which are the liquid form of water, or cloud droplets. And then you also have ice in the form of like snowflakes or ice crystals. And all of those can actually be present in a cloud at the same time. And there are a couple of different mechanisms that cause it to rain. One is called the Bergeron-Fine-Dyson process, named after 2 very smart scientists. And in that case, you have ice that forms in the cloud. Ice will act as like an attractant to the water vapor that's in the air, and the ice crystals will grow bigger. And then eventually they will start to fall. They actually grow, like instead of the rain droplets growing, the ice sort of accumulates. And then that falls and it melts as it's falling, and we get it as rain. That happens out of thunderstorms a lot of times, depending on how cold it is aloft. Another easy way to think about it is that you have collision and coalescence. So you have all these little raindrops, and they kind of run into each other and get bigger and bigger until they fall. So that's one of the other factors that can contribute to it. But basically, this is all part of the water cycle. You have heat, and you have liquid water that turns to gas. It rises just like a hot air balloon. And when it gets to a level called the condensation level, or the LCL, the lifted condensation level, it will look for something to condense onto, but it doesn't automatically condense. That's the interesting thing. Think about this. On a muggy morning, if you walk outside, you will find water on your car windows. You'll find water on the grass, like dew, right? But you don't necessarily have water just falling out of the air, right? It condenses onto something. And that's the same thing that happens in a cloud. It needs something to condense onto. And that's why rainwater is not completely clear. It's not completely pure. It has dust. You can have raindrops forming on dust, on salt, on things like pollen. It could be almost anything. Little tiny bits of organic matter that's up there. It needs something to form onto, and those are called cloud condensation nuclei. So the bottom line in all of this is that why does it rain? It rains because water changes phases, because it can exist as a gas, a liquid, or a solid in the case of ice. It happens because we have temperature differences at the surface, and as you go up into the atmosphere, it gets colder. And it happens because water vapor finds a tiny bit of something to condense onto. Just like it would condense onto your glass if you were having a tall glass of lemonade. The outside gets wet. Well, that's just like what happens up in the cloud, except instead of a glass of lemonade, it might be a little piece of dust or some salt or something like that. So that is sort of an overall view of why it rains. I mean, another basic reason that it rains is that we're a wet planet. 70% of the earth is covered by water. And so you have a constant transition of liquid water to water vapor, to ice, back to liquid water. So there's this whole water cycle. If we were a dry planet, like the moon or like Mars or like Mercury, doesn't rain there because there's no water there. And there's not much of an atmosphere there. So, well, no atmosphere in the case of Mercury and the moon. So that takes care of why does it rain. All right, the number 3 question from ChatGPT is, what is the difference between weather and climate? The easiest way I've heard it described is that climate is what you expect. Whoop, my light went out. Climate is what you, oh, come on now. See, I bought this light off of Amazon. Come on. Yeah. Climate is what you expect and weather is what you get. That's the way I've heard it explained. I don't love that explanation, but it is kind of gives you an idea. So if somebody were to ask you, what's Houston like in August? That's a question of climate. What's it like in August? Well, Houston's hot in August. August is the hottest month most of the time on average. It also tends to be kind of drier. So you would say, what's the climate in Houston in August? Well, it's very hot. It is very humid, and you have some occasional storms. And that's the climate in Houston in August. But the weather would be, today it's going to pour down raining, or today there's a hurricane hitting. You know what I mean? That's the weather. Climate is like, in general, what you expect for an area given a certain time of year, or you could even say in general, like you could say California has a Mediterranean climate, Southern California, which means that like in San Diego, the weather is generally dry and sunny and kind of goes back and forth between cool and warm, but that's the climate of San Diego. It's not an especially rainy place. If somebody asks what's the climate of Orlando, Florida, you would say, well, it storms there every afternoon and it's very humid. You know, so that's general climate. You know, what's the climate of northern Quebec? Very cold most of the year. So that's climate. And weather is, you know, for example, today, Chicago is like 98 degrees. Is that typical of the climate of Chicago? No, but that's the weather today. So when we talk about climate change, and because I just said the word climate change, under the YouTube video is because they detect what you're saying. There's going to be a little thing linking you to the truth about climate change, and get, you know, God forbid I'm saying something wrong. But when you talk about climate changing, you're talking about the general overall like 30-year average moving in one direction or another. You're not talking about weather on this day, which is why it's always one of those things where, like, you know, if it's snowing out or it gets really cold, that doesn't mean that the atmosphere still isn't warming and all of that stuff, because that's just weather versus climate. So there you go. How do meteorologists predict the weather? That's an excellent question, because it has changed significantly through the years. I mean, back in the old days, they actually were able to predict weather. They would mostly use it doing something like a barometer. They would look at a barometer, and if the pressure was falling, then they would know that maybe a front was approaching, because a front is like a dip in the pressure, what we call a kink in the isobars. And so if the pressure were dropping and it kept dropping lower, they would know that a storm system was coming, either in the form of a cold front or maybe even a hurricane or something like that. That's going way back. After that, we started to develop some tools, some better tools in our arsenal. Things like synoptic weather maps. That's going back 100 years or more, where we can get pressure and temperature data, and they would send it with a teletype, you know, that kind of thing. And then you can make a map, basic map of the country to see where the highs and lows are, things like that. So that helped. But in modern times, and I'm going to hit pause here because I have to do a quick weather here, and then I'll come back and finish. But in modern times, we have a lot of different tools that we use, including satellites. The satellite era began in 1960 with the launch of the TIROS-1 satellite, which was the first weather satellite. And since then, we've been able to take pictures of the clouds to get imagery both visually, what we call visible satellite imagery, or more importantly, infrared satellite imagery, which lets us track the clouds at night also. And that's how we can see hurricanes coming now that we could never see in the past. That's how we can see what I just showed you, upper level areas of low pressure coming in, which we would never be able to see in the past. So all of that data we can use to predict weather, but the most important tool we have, to be honest, computer models. The most important tool. The models are getting better and better and better and better every year. Are they wrong sometimes? Yeah. Especially on a day like today with scattered storms, they don't seem to do great with location and sometimes timing. But the bottom line is the global models that we have now, like the American GFS and the European Center for Medium Range Weather Forecasting, the ECMWF, their model, the Euro, an unbelievable amount of data, just millions upon millions of data points going into this model. Takes about 3 hours for the supercomputer to process it, and the output that comes out is, in general, very reliable. And these days we can do a 1 week, maybe a 10-day weather forecast. That's pretty great. And they even do go out to 16 days and beyond, where you just look for general trends. So computer model, the answer to the question here, how do we predict the weather? Largely computer models. Short term is going to be radar and satellites and some other various tools. I'll be right back. All right, number 5 is my favorite question. Why is the weather forecast sometimes wrong? The atmosphere is remarkably complicated, extremely complicated, as far as like laterally, like north, south, east, west. Where is the moisture distributed? How is the pressure distributed? We also have to worry about up and down in the atmosphere. And there are some parts of the earth where we have a lot of data and some parts of the earth where we don't have a lot of data. And so the computer models do their best to assimilate all that, but there are going to be holes in the data and therefore sometimes mistakes in the output. In a short-term forecast, like today, we could be pretty certain that it's going to pour down raining, but it's a little bit difficult to say exactly where. Like today, it definitely looks more likely south of Interstate 10, maybe along Interstate 10, and a little bit less to the north of I-10. But, all weather is local. In other words, the forecast might feel wrong because maybe there was a high chance for rain and it didn't rain where you live or work. And so in your sort of experience of that day, it didn't rain. And there might be some other part of town where it poured down raining. And so in the people's experience who lived there, it was a rainy day. So that does make it difficult. And that's why, we try to do this weather where you live, because sometimes the weather can be different in Texas City than it is in Katy. The weather can be different in Pearland than it is in Conroe. It can be different. So that's sort of the basics of it. All right, number 6, what causes severe weather events like hurricanes, tornadoes, and blizzards? Well, you could take up a whole semester of college, talking about this kind of stuff. But let's see, to boil it down, what are some of the more interesting reasons why it happens? Well, I would say when it comes to things like blizzards, tornadoes, and things like that, the Earth, well, first of all, the Earth spins once a day. And 365 days, 365 spins a year. And so that imparts a spin to anything that's moving, like water or air, or anything else really that's moving, but for the purposes of this, water or air. We also have 70% of the Earth covered with water. Some of it's warm, some of it's cold. We have the rest of the land. Think about just the United States of America, how different the land is in Utah or Western Colorado versus Texas. You have some parts of the country where there's huge terrain and you have mountains that are 4 miles high in the sky. And you have, maybe not 4 miles, 3 miles high in the sky. And you have, places like Denver that are the mile-high city, right? And then you have Houston, which is 50 to 70 feet above sea level. So you have the contrast of land and sea. You have the extreme terrain differences on land, and that causes things called differential heating. It causes waves to form in the atmosphere when the wind has to blow over mountains. It can sometimes form like areas of low pressure on the side of the mountain that the wind is blowing over, and that also happens to coincide with an area that's favored for tornadoes. So it's amazing how complicated it is. And in the case of our planet, generally you have a jet stream in the northern and southern hemisphere that in the mid-latitudes, like where we live, is going to be blowing west to east for most of the year because of the contrast between the warm equator and the cold poles. So between there, you have a temperature contrast and you get a jet stream there. And that jet contributes to things like blizzards and tornadoes and drives those kinds of weather patterns. Hurricanes are a little different. Well, a lot different. Hurricanes are different because they don't involve cold air or necessarily disturbances in the jet stream because they come from the tropics. And in the tropics, the whole point of the tropics is the temperature doesn't change. So basically anywhere around the world in the tropical oceans, the weather is going to be driven completely by pressure differences in the form of like convection, thunderstorms and things like that, tropical waves. So, and a lot of that's driven by the seasons. It moves to the north in our summertime and to the south in our wintertime as far as the formation of tropical systems, which is why we have a hurricane season. We don't usually get hurricanes in December, although it could happen, I guess. But yeah, so it has to do with the fact that the Earth spins, the Earth is tilted with respect to the sun. A lot of the Earth is ocean, some of the Earth is land. Even the land itself has some parts that are very jagged and bumpy and other parts that are very flat. So it makes the motion of air and the transfer of heat, the transfer of humidity and things like that extremely complicated, which also ties in with the previous question. Okay, so why does the temperature feel different from what the thermometer shows? Two main reasons. This is a quick, easy one. In the wintertime, it feels colder because it's windy, and whatever heat you have that's near your body that's making you feel slightly warmer gets blown off. And so that makes you feel colder, makes your body lose heat faster. And as far as the summertime, high humidity will make you feel hotter because it slows down the evaporation of sweat from your body. When your sweat evaporates, it releases heat during its phase change from liquid to gas. So it has to absorb the heat from your body to turn into a gas, and then you cool down. Let's see. What are the different types of clouds and what do they mean? Again, we'll kind of keep this on the simple side. You have like low, medium, and high clouds. You have clouds that produce rain and clouds that don't. The word nimbus or nimbo refers to rain. So if you have a cumulonimbus, it's a raining cumulus cloud. If you have a nimbostratus, it's a raining stratus clouds. Stratus is a layer. So that's like if the whole sky is gray in a layer, happens a lot in the wintertime mostly. That's a stratus cloud or a stratus deck. The poofy clouds are cumulus clouds. Sometimes they're friendly clouds, and if they grow too big, they could be very unfriendly clouds like we have out there right now. Cirrus clouds are my favorite. Those are the ones that are very high in the atmosphere and they're made out of ice. And I like them because ice can act as a prism and can split the sunlight and create some really neat visual effects in the sky. So the clouds are separated by whether or not they're raining or not, what level of the atmosphere they're at, and then you can combine different types of weather. Like a stratus cloud is a layer. A cumulus cloud is poofy. You can have poofy clouds in a layer, which is a stratocumulus cloud. You can have poofy clouds that are high in the atmosphere. Those are altocumulus clouds. Or cirrocumulus clouds. So that's how they all connect. They're basic types of clouds, and then you use them together to make combination clouds. Like an altocumulus or an altostratus or a stratocumulus. It's really fun. Why does the weather change so quickly? Well, this is amazing. The weather changes quickly here, mostly because of rain or fronts. And that actually brings us to number 10, which I'm going to kind of combine these. Why does the weather change so quickly? And then number 10 is, what is a weather front? How does it affect the weather? A front is a line that separates two different air masses. So in the wintertime, you can have a sort of a warm tropical air mass over Texas, and then a very cold, dry Arctic air mass coming down out of Canada. And where those two meet up, you get a front. And depending on what direction the front is moving, it's either a warm front or a cold front. Now, there are some complications to that as far as when you go above the ground, there is a cross section where a cold front looks more like this, where the cold air kind of is like oozing, kind of like spilling syrup on a table. I don't know, molasses or something. And then a warm front is kind of more like that, where the warm air is moving over it like that. But regardless, a front separates two different types of air, two different temperatures of air. Generally, the cold air is dry. So that's a front. And the reason why weather changes so fast is that fronts move. They're driven by the jet stream and areas of low pressure that form. And so when the front comes through, the weather changes dramatically. And a lot of people in Houston will say, if you don't like the weather, wait 5 minutes, that kind of thing, which sounds true, and it is true sometimes. But the most dramatic weather changes across the United States are going to happen across the Central Plains, places like Nebraska, South Dakota. Those are the areas that are going to have incredible changes in weather, especially temperatures. And so they could have their temperature drop from 70 degrees to 10 degrees in a day, way more than Houston would have. Not to diminish the changes that we have here, but I mean, some of these, like the all-time records are something like dropping 40 degrees in an hour or something, just insanity up there around the upper plains. So anyway, that's going to do it for Mondays with Mike. It's National Dog Day. So happy National Dog Day to you. And I don't think that Pippin and Goose are going to be watching, but they're probably home sleeping right now, or they might be digging through the trash for a turkey bone. They're probably doing that. My mom and Neil are up in Pennsylvania. I think they still are. Maybe they're home right now, but they're visiting my Aunt Pat and my cousin Kathy and Tommy and everybody else up there. So when they got up there, I think the overnight temperatures were in the 40s, which is pretty awesome, although I think it's hotter there today. So anyway, shout out to everybody. Hope everybody has safe travels. Happy Dog Day. Hope I helped answer the questions of the 10 most commonly asked weather questions. And maybe next week I'll ask ChatGPT for the next 11 through 20, because I love answering stuff like this. Have a great day, everybody. See you next time. And I hope you enjoyed Chatting with Chelsea that came on at 12:30. So it'll be daily at 12:30.